In this video, we are going to talk about geometric sequences in series. So a geometric sequence is a sequence where the same number is being multiplied or divided. To get the next term in the sequence. The number you multiply or divide by is called the common ratio. And we use the letter R to show the common ratio. So just like arithmetic sequences, geometric sequence has an explicit formula and a recursive formula. So the explicit formula is using the first term in the common ratio. We have a sub 1 times r to the n minus 1 power. So it does model an exponential growth or just an exponential function equation. And then our recursive formula is where we say the first term, and then we say that a sub n equals our common ratio times our previous term. So this right here and this right here is the common ratio. Again, a sub 1 is going to be our first term. So in example 1, we want to determine if the following sequences are arithmetic, geometric, or neither. If it's arithmetic or geometric, we're going to write the explicit formula and the recursive formula. So if we look at number 1, if I try to go the arithmetic route, I would add 1 to get to this next term. But when I go from 2 to 6, I would end up having to add 4, which means we are not adding the same number each time. So this is not arithmetic. Okay? So arithmetic does not work. So then I look at the geometric route. From 1 to 2, I would multiply by 2. From 2 to 6, though, I would need to multiply by 3. So therefore, we are not multiplying by the same thing each time. So this is not geometric. So since it's not arithmetic or geometric, it is neither. Looking at the next one, I see that it goes from 81 to 27. So what we could do is we could check for geometric first. And so to find that common ratio, we could take the second term divided by the first term. And so when we do that, we get 1/3. Well, if I multiply by 1/3 again, I do get 1/9. If I multiply by 1/3 again, I do get 3. And if I multiply by 1/3 again, I do get 1. So multiplying by 1/3 is the same thing as dividing by 3. So since our common ratio is multiplying by the same number each time, this would be a geometric sequence. And so we can write the explicit and the recursive formula. So starting with the explicit, the two things we need is the common ratio, which we found right here, and our first term, which is 81. So we have a sub n equals our first term times our common ratio to the n minus 1 power. Then for the recursive formula, we need the same things. So this time I just say a sub 1 equals 81. And a sub n is equal to my common ratio times the previous term, which is a sub n minus 1. And that is everything that we need for this one. Looking at the next one. Okay, it doesn't look like it's going to be geometric to me, so let's go ahead and check to see if there's a common difference, to see if it's arithmetic. Remember, we can take the second term minus the first term, and that gives us 5. So from 5 to 10, I add 5. From 10 to 15, I add 5. And from 15 to 20, I add 5. And from 20 to 25, I do add 5. So this is an arithmetic sequence, and it has a common difference of 5. So when we go to write the explicit formula, that's what we did in class yesterday. We have a sub n. We need our first term, which is 5, plus our common difference, which is also 5, times n minus 1. And that would be it for our explicit formula. For our recursive formula, we need the same things, it's just written in a different way. So I need to state my first term, which we said was 5. And then we're going to have a sub n equals our previous term. And this time we're adding 5 for a common difference, so plus 5. And that would be it for this. So that's a little bit of a review of what we did yesterday and some new stuff for what we're doing today. Now, example number 2, we have the third term of a geometric sequence is 64, while the common ratio is 2. So a couple things. We know that it is a geometric sequence, and we were also told that the third term is 64. So a sub 3 equals 64. But something that may be a little more helpful is if we write it out and make it look like a sequence. So we know we have the first term, we have a second term, we have the third term, which is 64, and then we don't know anything after that. But we do know to get the next term in the sequence, we are going to use our common ratio, which is 2. So to go from 64 to the next term, I'm going to multiply by 2. When I multiply by 2, it would be 128. But we want to write the explicit rule and the recursive rule as well. So that means that we need to know this first term, a sub 1. Well, if I'm getting the next term by multiplying by 2, if I go the opposite direction, so if I go from here to here, I'm really going to multiply by 1/2. Well, 64 times 1/2 is 32. I need to multiply by 1/2 one more time, and that gets me my first term of 16. So now I know my first term is 16. We know that our common ratio is 2. I have enough information to write the explicit rule. So that's going to be a sub n equals 16 times my common ratio of 2 to the n minus 1 power. And that is it for the explicit rule. Now, if I want to find the 9th term, all I have to do is plug in 9 into my formula. And so I am going to have 16 times 2 to the 9 minus 1 power. And then you're just going to type that into the calculator to see what it gives you. So when we type it into the calculator, 16 times 2 to the 9 minus 1, or 8 power, we get 4,096. And that would be the 9th term in the sequence. So if we continued this pattern until we got to the 9th term, we would get 4,096. Right now we only have the first 4 terms. Then we are going to write the recursive formula. So the recursive formula, we need 2 things. we need to say the first term, which we determined was 16. And we need the A sub n equals our common ratio times the previous term. And that's it for the recursive formula. Okay. Moving on to the back where we talk about the sum of a geometric series. So we have two different types of geometric series for sums. First one we have is for something that is finite. That means that you are given a specific number of terms to find, and you will use that formula. The second one is when it's an infinite geometric sequence, you will use the second one. But this only happens when your common ratio, the absolute value of it, is less than 1. It cannot be greater than 1. So, in example 3, find the sum of the first 10 terms of the series, 1 plus 5 plus 25 plus 125 plus ... So we are given a number of terms we want to find the sum of. So we're going to use the first formula. So that is S sub 10, because it's the first 10 terms, is equal to my first term, which is 1, times 1 plus my common ratio. So to go from 1 to 5, I multiplied by 5. If I keep multiplying by 5, I do get the next term. So my common ratio is 5. It is being raised to the n power, which n is 10. And then on the bottom, it is 1 minus my common ratio, which is 5. Now, I did realize that I accidentally put a plus sign, and that should be a minus sign up at the top. So we are going to go ahead and type this in to our handy dandy calculator. So when we type it into our handy dandy calculator, we do get a really, really big number, but you got to think this is growing at a fast rate. So the number should be really, really big. So we get 2,441,406. So that would be the sum of the first 10 terms. Looking at our last example, find the infinite sum of the series. So infinite means we're not given a number. So we're going to use that first formula, but we do need to make sure that our common ratio, the absolute value of it, is less than 1. So to find my common ratio with this, I can take my second term and divide it by my first term. When I do that, I get 1 over 8. So the absolute value of 1 over 8 is less than 1, so it works out, and I can use that formula. So we have S equals our first term, which is 512, divided by 1 minus our common ratio, which is 1 over 8. So all we have to do is type that into our handy dandy calculator. And when we type that into our calculator, we get 4,096 divided by 7. And that would be our sum of the infinite series. So if you have any questions over any of these examples, please make sure you ask in class or write it down so you don't forget.